Hello and welcome everybody to today's Open Telekom Cloud community webinar, as usually hosted by the Open Telekom Cloud community. This time we have a product manager colleague together with us, Christian Bölle, and we will have today a great session about when speed matters. Leverage cloud-based caching on Open Telekom Cloud, so you will get a lot of useful information about the DCS service. With this, I hand over to you, Chris. Thank you a lot for having you here, and let's have a great webinar. Thank you, Chris. Let's rock.
Okay, Stefan, thanks a lot. Also a warm welcome from my side. So today we would like to talk a little bit about our DCS service, which is the distributed cache service, and what we all can do with it. I'm going to cover actually three big parts about the use cases, the so-called caching strategies, the data structures which we can implement inside of a cache. Then we will have a more detailed look into our specific flavor types. What do we offer today from the Open Telekom Cloud? We will talk about key functionalities and features, what the DCS can offer, and we will see also how the caching service works in detail in a live demo. Okay, good. Then let's start. What are the common use cases for DCS? This is just a list of the things which are most commonly used. Definitely, it is very common as a session store, distributed log and content caching. Those use cases we will see also later on, as well as there is a lot of advantages in this DCS solution. For example, when you do a real-time analysis where you need a lot of information, a lot of data aggregated in a sub-millisecond kind of response time, as well as, for example, when you want to implement high-speed transaction processing. Yeah, so we will see that later on as well. This is the list now. I will not go through all of that. It's a little bit text heavy, but this is more or less for references. In this slide, I've collected a little bit more details about the use cases, when it's used and for what kind of procedures. And I will not go through all of that because that would be a little bit boring. So the next part of it is that what are the caching strategies, more or less from the architecture or from the design perspective? So there are typically 5 caching strategies, what we have in the field, which are called cache aside pattern and write around pattern. So these 2 patterns are used when you more or less you have an existing infrastructure, most of the cases using a database with an application server who is responsible for the processing, and then you add a cache system on top of it to improve the performance of your existing application. So this is a very common use case that you, for example, deliver from a web server information about the product details, how many parts in the web shop or how many articles are still on stock, what is the default picture to it, and. And with those patterns, you typically try to take load away from your database, which is frequently needed for the website to be presented and handed over to the user. And this is a very common part. And then there are also other caching strategies where it's not like an optional add-on, then the cache service becomes an integral part of your system design. This is then, for example, a read-through, a write-through, or a write-back pattern. That's how it's called. And in these cases, this is also why they are colored in a different case, is that the cache is not an optional thing to help you to improve performance, but it's a mandatory part of the application, which then also inherits, you can say, the SLA and the availability needs what a database typically offers to you. And this is where we will later look into what flavors and types of DCS can fit for what purpose. Okay, good. Then the next, here we see now a little bit the data structures which are offered by the DCS service, which is actually a Redis database behind. So you can see, for example, what you can do. You can store strings and binary data, hashes, lists, sorted set, and the last three, they are a little bit, I would say, they are special data sets. They are, for example, used when you have to calculate the distances between 2 points. This is often used when you have mobile apps which support point of interests nearby search capabilities, and we have hyperlooks and streams, which are special use cases for that. And here you see also already this is different to a database, because a database offers you a lot of more complex data structures, different tables with foreign keys, and this is not possible in a cache solution with Redis. Here we are talking more about simple data structures. And in the next slide, I have also compared a little bit DCS with a classical database, because there are three, you can say, important things which are advantages of a Redis-based cache solution and also disadvantages compared to a database. For example, the data schema, which you maybe know from MySQL, this is not supported in a Redis database. There are different commands used, like you cannot use a select star from like what you use in a database. You have to use different commands when you operate with a cache. Then also, for example, triggers are not supported. Here is a little add I have to do. So you can also implement a trigger-like solution with a cache. This is then the so-called Lua scripting, but officially it's not supported, and especially it is not supported in the transactional context like a database would support it. Then the next thing which is very different, which the scaling part, when you operate a Redis cluster, we will see that later on, sharding is supported, but a horizontal partitioning like the database cannot be done with a cache. And I think one of the most important differences are the last two things here. So when a database offers you immediate consistency, which allows you to be very sure if you commit a record to a database, it is written and it's stored. This is slightly different in a cache because it operates on a so-called eventual consistency. It's 99.9% sure that you write something into the cache, but to this atomic execution, there is a slight difference to the database that you cannot be 100% sure. And this is also the transaction concept, which is different because in a database, you can define your isolation levels. You can decide that, okay, I'm exclusively reserving a record in a database. No one else is able to modify this and all these kind of advanced features of a database. This is not possible when you use a cache solution. But on the other side, there are also a lot of advantages of having a cache solution. And we will see that also later on, especially when we talk about speed and processing of storing informations. Okay, good. Now, I would like to give you a little bit overview of the three different, we call it flavor types, but different cache solutions what we offer. So the first, a single cache is actually it's the most simplest installation. It is a Redis which runs on an ECS, which is offered from our DCS service with a specific size, and you can start connecting with it. You can read and write to it in a single instance. It's typically used for testing or when you want to have this write-around pattern. Then the second part, this is a so-called master-slave ECS flavor, which brings a great capability that you have not only one data store for your in-memory data, you can also replicate that. That brings a lot for your availability because you can be sure that you have a second instance, like a replica called, you have a replicated instance, which can take over the load as well as holds the data in a second source when something happens to your master node. And the third, which is definitely the most advanced when we talk about availability and resilience, is the so-called cluster. And this cluster is using a sharding. And I've tried to explain that here. Sharding is actually a concept which it's like a cake, and the cake is 100% of your data. So you have, for example, a 4 GB cluster, and this 4 GB cluster is the entire cake. So what happens now is with sharding we separate this 4 GB into 3 different pieces, and every shard holds one piece of your cake. So it means you will have more or less 1.33 gigabyte in every piece of the cake, and every piece of this cake then also has a replica in another AC to bring in the high availability. So that is a little bit different than when you compare it to some clustering mechanisms of databases. But this is important that sharding divides the overall memory into specific pieces. Compared to a replica, when you have a 4 GB master system, you have here in the master 4 GB, which is then replicated in another 4 GB into another AC. Okay, very good. Now, the next thing, we want to look a little bit into the key features of the DCS. What does it bring, especially on top of the Redis functionalities, which are provided from the open source community? So what is very convenient on our Open Telekom Cloud is to manage the instances, changing parameters, for example, activating or deactivating SSL, managing the access lists, this kind of things. Then we have a command line interface, which we will also see later on, which is very useful, as well as cache analytics you can perform like hotkeys, expired keys. And especially for our flavors which support high availability, which is the master slave as well as the cluster types, we offer backup and restore of cache data. So we back up the data into our OBS buckets. Then you can also perform a switch over from master to replica, as well as switch over from shard to replica shard. We will also see that later on. And I've given you some examples how this looks like. So for example, the backupping functionality and restore, which you can do with one click with the Open Telekom Cloud console. Then you have here an example how this web console can look, how you change parameters, for example, for tuning the cluster, as well as you can do online migrations and online scaling. This is very useful, online migration, for example, when you want to upgrade a cluster from, I've just done this recently from a Redis 5 to a Redis 6. So this is very convenient that you don't have to manually export and import all your data. So we have this integrated in our console that you conveniently can specify a source DCS system, a target DCS system, and then the migration is done automatically. Okay, now the next features I just wanted to show you shortly, this is that it's also integrated completely into the Cloud I system, as well as you can do the permission management with IAM as it is for other services. Okay, good. Now, I think enough of PowerPoint. So let's get into more details using the cache. You might have seen the API Gateway demo. This was 2 months back. I've given that. And what we have done here is that we have an API Gateway, which is using a system. Today, we want to look a little bit behind the scenes of this API Gateway, how we use the cache, how does it look, and how does it work. So we will not focus so much on the API itself, but we want to look into this part of this demo. Maybe just a short reminder. So this API, what does it do? It's using our API gateway, and it's providing us information about our data centers of the Open Telekom Cloud with the current weather situation, the temperature, as well as the weather. So we see everywhere it's cloudy, just in Netherlands and Iberia, the sky is clear. So far, so good. The API is working. Now, what happens behind that? So you can see this information is from actually just 15 minutes old. This runs on UTC. And we have read this information from our cache. So why is that happening? So the API which we are using is the Open Weather API. It is hosted on the US. And this, when we now would call an API directly from our API gateway, it would increase the latency of our API a lot. Secondly, the Open Weather API has some rate limits, which So we cannot call this API a couple of hundred or 1,000 times a day. So what we have done is we have done it in a way that we call the API on an hourly basis, store it in our cache, and the cache now returns this information on this 100 or 1,000 calls what you can operate now on this API grid. And this is the use case of a classical caching. So we read the information once, we put it into the cache, and the cache now provides this for all interested users, and you can run and call this API as much as you want. But the information will not change within 16 minutes. So this is a classical use case of the DCS. The second use case, when I click here, this is the information which we use during the API gateway demo, where we see how many requests and what is the response time of the API gateway. Today we will not look too much into that, but this information here, we also read from the cache. So now I think it's time to look into the cache itself. So I'm using here a tool which is called Redis Commander. It's a very useful tool which brings us, or which shows us the cache structure what we have created. And what you see here now is exactly this DCS instance running behind the demo. And what you can see here is that I have used so-called namespaces in DCS to build a structure inside the cache database. So you can see here API demo, and here you see a couple of elements which I have put. So for example, the locations, which you just have seen on this API, when we go back, it has 6 locations and the temperatures. Now let's see how the cache structure looks behind that. So you see here also the 6 locations, for example, DE1, and what you see now is a hash map which is placed in the cache containing country, city, longitude, latitude, also the geo information of that location. Then you see the weather summary, you see the temperature and the wind speed, which is currently stored from this location. And this is a structure which is placed as a so-called hash map in the cache itself. And you see all the 6 locations, you see the attributes next to it, and when the API gateway now asks the cache, it exactly is doing this. It is telling me, show me all the 6 locations. Then we get the keys, also for Switzerland 1 and 2. Then we see the 2 keys for Germany and for Netherlands. And the weather load information, by the way, this is the time when the last time we refreshed the cache. This was exactly this time here. So 80190. So this is this information. So now we see how the cache looks like. We see how you can organize a cache. And even, by the way, I really recommend that you use these namespaces, because theoretically you can put all the information in a cache into the root, but it's a little difficult to maintain this. Now, the second part which we have seen was the report for the backend audit. So we have seen, okay, there is one cluster node which is currently processing 10 requests, and how this works. And this information is also here. Under audit, you see the status, the audit is completed. Summary, starting time, how many threads we will see here. And as well, you see all the records which has been shown here in this table are part of this record information. So when I go to a record, you see exactly the information which we have seen in the web page. So this is actually, you can see that's the data storage behind this page here. And whenever we go here and load this page, this information is retrieved live from the cache. So now we have seen how you can structure this cache information. I think I would like to explain you a little bit how we do this. When the application is using that cache, it's using something like SQL and DML. Slightly different in case of Redis, but what I can show you is, for example, when I go here and perform a set command. Set means I want to store a simple string in a cache. I will go webinar title, for example, and then matters. So now what happened is, you see a new namespace got created, not the API demo. Now we have a new namespace, which is webinar. And webinar, there's a title, and the speed matters. So you always have to remember that Redis is a key value database. So the key is always the identifier to find your data, which I have used now. I have defined the key, which was actually webinar double point title. Means the double point is the separator for namespaces. And the title is now the key, and this is the value when speed matters. Perfectly fine. So we have written information in our cache. Very nice. So now the information, maybe I want to extend, and I want to say, okay, the title is not enough. I maybe want to add more information about the webinar. Then I could use, for example, a hash set. And when I use the command hset, I'm starting to creating a hash map. How do I do this now? Webinar data, for example, I create. And then the first attribute I want to set, okay, we start at 10, we end at 11, and then I perform this call. And now the cache tells me I have created a hash set with 2 entries. And as you can see, the symbol even slightly changes here. Now we have webinar data, which is start and end date. The advantage of a hash map now is I can even extend that because I've maybe forgotten something, and I go again, hash set, data, and I have forgotten the time zone, which is CEST. So now, as you can see, the key is still the same. I'm always using webinar data, but I've extended it now even with the time zone. So I've added a third attribute into my set, which is very useful now when I want to, with one key, read multiple information. When I just use a simple string, then I can only read one value with one key. And here with a hash set, I can read multiple data with one key. When I started using now this hash map, I actually don't need my single string anymore. So what I can do is I can delete it with the del command, but I also want to show you something nice which we use a lot when we operate with the caches, the so-called time to live. Time to live is the indicator which tells you how long something is stored in the cache. A lot of times we have informations in our cache which we don't want to store infinite. We maybe want to store only for 1 hour. And there's a very simple way to use this with Redis. You just define expire, now the key, webinar title, and I say, okay, keep this for 10 seconds. If I define this now, what you can see is the time to live is counted down. As you can see, I refresh it. And if the time to live has reached 0, the information is gone from the cache. It's already deleted. So this is very useful when we want to cache information and want to avoid that our memory is overloaded, that we give it a time to live. You can not only give only time to live about like 10 seconds or 1 hour or 24 hours. You can also define, okay, I want to expire it exactly at midnight. That you can then also use, for example, timestamps to do that. Very good. Then we have seen that there's a lot of more what you can do. The commands and the data types we have seen is quite a lot. Just wanted to give you some introduction into it. And when we now go back to our API gateway demo, I want to show you something else. So now here we had this feedback API to post information into the system. Now let me use that shortly, this API. So I use that and see it's already processed. Feedback accepted, caching is great. So now what happened is, go back to our API demo, and here there is now a comment newly added into the element which says exactly caching is great, and I've given 4 stars. This is now the way how you can interact with this cache service. So the application, the APIs, write into the cache, they read into the cache. You have seen how you can even set informations yourself to it and how you can use it. Now, you might have seen that there is this so-called EF2M system, which I'm connecting and I'm using to that, but there's also that EF2R system. And this is the replica of exactly this system, because what I'm using for this demo is a replicated cache system. Means I have a master. This is the master which you have seen here, and I can even show you how this works. Yes. So this DCS system is in the role master. Maybe I shortly show you how it looks in the Open Telekom Cloud. So I have actually 3 systems, a single, a master standby, and a cluster. And I'm using this one here, this one. And this is a 2 GB DCS in-memory database, which holds a replica. And you can see how it works. There's one master and there's one replica. And the same I also can access in my Redis commander. Now, the good thing is you have seen that we have set these 3 informations on top of your webinar. And if I open the replica, you see exactly the same data. So means during that demonstration, which I showed you that how to add this data, it got already replicated. It is replicated instantly. So whenever I've performed here this hset command, which was storing information, it was immediately on the replica. This is a great feature. So I can also connect to the replica itself. If I have now, for example, a read-only application, which only has to read information from the cache, I don't have to use the master. I can put them on the replica to share the load against this information. So now what do you think would happen if I try to change the data on the replica? We can maybe try that and say hset. I want to add one more, maybe the title again. Okay, now you're seeing what happens. I cannot change the data on the replica because it is read-only. And that's actually also how it expected to work. So I can only place this command, hset webinar title, in the master. I go back to the master. When I put it here and refresh the data on the replica, it's immediately there. There's also one more comment one more hint I want to give. The default replication setting when you create a DCS HA flavor is that everything is replicated instantly. Means before the command returns to the client that data has been accepted, it is ensured synchronously that it's also written to the replica. This has advantages and disadvantages. For example, when you write with a lot of threads into the cache, it maybe even makes sense to replicate asynchronously, and you can change that according to your needs in the console. Just want to give that hint. Default is we replicate synchronously to be 100% sure that the replica holds always the latest information. And the second option is to replicate behind, for example, every second, to avoid that too many threads have to wait for the replication mechanism. Okay, good. Now we have seen the replica, we have seen the master, how it works, and also how the demo works. Perfectly fine. Now I want to shortly give you a little introduction into that system which I have here. This is the so-called Redis cluster. The Redis cluster is a little bit different, and what I want to show you here is this so what I'm using now is our inbuilt web command line. So this web command line is similar to what you have seen here in the Redis commander, which I used here. The great advantage of this web command line is that you don't need any application server or any system who is accessing the cache. This is very useful, especially when you have whitelisted the access to a cache, which you can do here. And maybe shortly show this. The instance configuration has a whitelist, which you can create that only specific IP addresses can access your cache. If you do that, you might need this web CLI to access your cache then. And now I want to show you what is different and what is the nice thing about a Redis cluster. So there are a set of commands when you use a cache system, which are only available when you use a cluster. I'll give you one example. This command, for example, is only available when you use a Redis cluster. And now you see actually what I meant before with the cake. So what you see here is my Redis cluster consists of 3 master and 3 slave nodes. Also 3 masters in one AC, which separated the cake. So everyone is holding one piece of the cake. And the slave nodes hold the 3 pieces of the cake on the replica. Now, how does this work? Because at the end, I'm not aware which shard is used for what kind of cache. And to be honest, I also don't want to know that, because as a client of a cache system, I just want to store and retrieve information. There is a very smart concept behind it. This is so-called hash slots of keys. So what you see here is these numbers behind every master is indicating how the cake is sliced. For example, this master node here holds all the hash keys from 0 to 5,460. The second one from 5,400 to 10,000 something, and the third one from 10,000 to 16,000. So this is actually the internal mechanism how Redis is breaking your cake into 3 parts. So now what I can do is, or what I want to show you is, more or less, let's store 3 times a key in our Redis cluster. And how we can do that is we can let Redis help us to predict in which cluster shard a key will end up. I'm using a command which is called cluster key slot A. This command now helps us to identify if I use the key A, the protected slot will be 15,495, which means it will end up in this shard because it falls into this range. And let's do that. Let's try to do that. I set a key of A with value 1. Oh, it worked. Now I set a key of E with 2. It also worked. But now let me see in which key slot B falls in. It's just 3,300. This means this number here falls into this range. Means the key of B falls in a different shard than the key of A. And if I would now proceed to say set C to 3, and I want to see now which key slot is used for C, you will see 7,365. This is falling now into the second shard. So what is happening is that Redis is using every key and defines from the hash set of the key more or less in which shard it will fall. And the cluster works in a way that all these 3 so-called hash slots, or hash slots are defined from 0 to 16,000, they're equally distributed into 33% goes into shard 1, the other 33% goes into shard 2, and the rest goes into shard3. So how this now works, if I want to read from a cluster, if I do a simple command like get A, now it worked, it told me 1. I set it to 1. But actually what is happening is that we know that A is in 15,495, means I am right now connected to the third shard of the cluster. To be honest, this is the very great advantage of the cluster. I can connect to any node of my Redis cluster created by the DCS system. And when I wanted to read now the first key, which was A, the current node was already responsible for this hash set, and it returned it. Perfectly fine. So we know that A is 15,000, and I am right now connected to this master, which is responsible for that. Perfectly fine. If I now want to read the second key, it also worked. It gives me the value 2, perfectly fine. But what happened internally? Internally, the cluster has identified, oh, B is the data set of 3,300. I'm not responsible for this shard. It's not my piece of the cake. So what it does, this master has forwarded this request, 3,300 to the responsible node, which is in our case this one here, because it falls under the hash set of this one, and said, hey, shard number 2, your hash set, your piece of cake, handle this command for me. And then the second one said, yes, that's my piece of the cake. I will return the data for B. This is how it works. The cluster has divided the cake into 3, and whenever you talk to one of the cluster nodes, it always decides, my piece of cake, I will handle it, and if not my piece of cake, I will forward it to the right node, which handles this piece of the cake. I know it's a little technical, but I think it's a great concept to identify. And the good thing is, when you now use from Java or C# or Go, whenever client you use, you don't have to handle this. You just go to the cluster and say, store this information, and everything else the cluster will handle. It will identify which master node needs to be addressed, who is doing the work, and this is something which you have to worry about. This is a great advantage of the cluster. Okay, perfectly fine. Now, I would like to give you a little bit more details what happened. As just last month, we activated the DCS API version 2, how we call it. This version 2 brings a lot of advantages, especially about, for example, the SSL management, which is available now since for Redis 6, the instance tagging, enhanced cache analytics. The API is much more powerful than the version 1. Just want to remind you, if you maybe use the version 1, please upgrade. It helps a lot, as well as also we have fixed some bugs. The second thing is I want to show you some information, some upgrade on the Terraform provider. We have also implemented this version 2. It would be important also to upgrade your Terraform scripts to use DCS for version 2. And the last short information I wanted to give is that there is something which is very useful, which is not maybe used so much, is Redis itself. Our DCS can be also used as a messaging system. Messaging system, I would say, in the classical ways, we have solutions with ActiveMQ or Kafka, something like this. You can also do streaming and messaging with Redis. I have one example here. There is a stream open for the comments received by the API Gateway demo. And as you can see, there are currently 4 messages stored. Those 4 messages are stored to be processed from the processing nodes, which are right now not activated. That's why they are not picked up. But this is a way how you can use the cache system even for messaging. So we have just recently published a community article how to use this messaging with some examples. And the last thing I wanted to give you is that at least there are so many commands with Redis, and they are maybe not known to everyone, there is a very nice cheat sheet available on the internet, which has a lot of nice and good examples about what commands are there in Redis and how to use them. Stefan, I think I would be done with my presentation for today. I hope it was interesting.
It really was. So thank you a lot, Chris, for having you here. Now, the very last point is just the Q&A session. All right, one question is there. So it's the following. Can we do online migration from other cloud Redis to DCS for Redis? If not, then how we do backup import through RMAN?
Very good point. In the last version, when we upgraded this, we also activated a big new chapter in our DCS documentation, which is all about migrating from on-premise Redis installations to other cloud server providers or to our own cloud providers. So you will find here a lot of information about how to do data migrations from self-hosted Redis, between DCS instances, and also from other cloud providers. So there are a set of tools and a set of guidelines available how you can do that. And once you are using a DCS system on OTC, then it's even possible that you can do an automated migration and upgrade even between two DCS instances, yes. But you can also import cache systems from other cloud providers as well as from self-hosted. You will find this chapter here in the documentation online.
All right, thank you a lot. I hope this was the answer you expected. And in the last slide, you also see the contact details from Christian. So when there is anything needed on top, then please contact him. So please drop an email to him, and then he will for sure be happy to support you in whatever need you have there. Then I will close the session. So thank you a lot for being part of this webinar or being part of this webinar. Thank you a lot for joining us. See you in the next webinar. This will be again announced on the Open Telekom Cloud community portal. So if you are not already a registered member of this community here around about the Open Telekom Cloud, then feel free to register. It's totally free and very, very useful. Thank you a lot for having you here. Thank you a lot for being here, Christian, and see you in the next webinar. Thank you a lot. Bye.
All right. Bye.